Hello everyone. Today we will discuss Newton's second law of motion. According to this law, the net force acting on a body is equal to the product of the body mass and its net acceleration. Mathematically, we can write it as F net is equal to mass of the body into net acceleration of the body. Or in other way, we can define Newton's second law of motion as the time rate of change in momentum of a body is directly proportional to the applied force on that body and takes place in the direction of the force. You know that as momentum is a vector quantity and force is also a vector quantity, so in which direction we apply the force, the change in momentum takes place in that direction. Here, let us say in this diagram, a body is placed at point A and its mass is small m, and let us say its initial velocity is vi. Then its initial momentum will be m into vi, and let us say it is denoted by pi. When we apply a force on this body, let us say it reaches at point B. Under this force, as mass remain as it is equal to small m, and let us say at point B its velocity is represented by vf, then its momentum will be pf. pf will be equal to m into vf. Now according to the statement, we can write applied force F is proportional to delta P upon delta T. Delta P is change in momentum and delta T is time duration from point A to point B. Now we can write F is proportional to delta P is because change in momentum. So we will write it as final momentum of the body minus initial momentum of the body and divided by delta T. As T is equal to mv, so we can write F is proportional to mvf minus mvi upon delta T. We can take m common here, so F will be proportional to m in bracket vf minus vi upon delta T. Vf minus vi, it is change in velocity of the body, so we will write it as F is proportional to m delta v upon delta T. Delta v upon delta T, you know that it is equal to acceleration, so F is proportional to m into a. If we remove the proportionality sign, then we can use a constant k, then force F will be equal to k into m into a. For simplicity, we write k as equal to 1. So the Newton's second law mathematical forms becomes as F is equal to mass into acceleration, or in vector form we can write it as F vector is equal to mass into acceleration as vector. The SI unit of force is, you know that it is Newton and it is represented by capital N. We can write 1 Newton as equal to 1 kilogram into 1 meter per second square. If a body has mass 1 kilogram and if we want to accelerate it with 1 meter per second square acceleration, then we will need a force of 1 Newton. The other unit of force in CGS system is dyne and it is equal to 1 gram centimeter per second square. Now here let us see a problem related to Newton's second law of motion. Two horizontal forces act on a body F1 is acting in the direction of positive x and F2 is acting in the negative direction of x. The value of the force F1 is equal to 4 Newton and the value of force F2 is equal to 2 Newton and mass of the body is 0.2 kilogram. Here we have to find net acceleration in the body because forces are applied in the direction of positive x and negative x. So we will consider a net force because in the positive x direction a force of 4 Newton is applied and in the negative x direction a force of 2 Newton is applied. So here we will see that the net force will be equal to F1 minus F2 because 4 Newton force is acting in positive x direction and it is higher than the F2 force. So F1 minus F2 and divided by m. M is mass of the body which is equal to 0.2 kilogram. So acceleration in the positive x direction of the body will be equal to 4 minus 2 divided by 2. When we solve it, it comes out to be 10 meter per second square. So here the body will be accelerated in the positive x direction with an acceleration of 10 meter per second square. Thank you.